Welcome to Study Loop.
This is chapter 37, problem number 36. We have electrons accelerated under a potential difference, and their kinetic energy is also given to us as 7.5 times 10 to the power 5 electron volts. Let's convert this to joules. 0.5 times 10 to the power 5 times the charge of a single electron is gonna give us the kinetic energy in joules. I'm converting it right away because in the equations, you know that we need to use the energy in terms of joules. Now, going back to the problem, what's asking the problem is the ratio of the velocity of the electron over the speed of light. So we're basically looking at V over C, which, as you know, this is called the beta, and this is embedded in the gamma factor, the Lorentz factor. Lorentz factor is 1 over square root of 1 minus V squared over C squared. As you can see, we have V over C here. We can rewrite the Lorentz factor as 1 square root of 1 minus beta squared. So how are we going to get there? Well, in the kinetic energy equation, for the relativistic equation, gamma minus 1 times mc squared gives us the kinetic energy. So in this equation, we know everything other than the gamma factor here, right? So I'm going to try and isolate this gamma factor actually with the ultimate goal of going to the beta, right? So if we do gamma minus 1 then is going to be equal to kinetic energy over mc squared, right? If you divide both sides by mc squared. From here, gamma then is kinetic energy over mc squared plus 1. Now, we know that gamma equals to 1 over square root of 1 minus beta squared. So now what we need to do is to find out what beta is. In order to do that, I'm going to have to take square of both sides, right? So that I can get rid of this square root here. Then on a new page, kinetic energy over mc squared plus 1 squared is going to be equal to 1 over 1 minus beta squared. Now let's do the cross product. Multiplying the one in the denominator on the right hand side by the term we have on the left hand side here. So 1 minus beta squared from here is going to be then equal to 1 over kinetic energy over mc squared plus 1 squared. From here, then, if we want to isolate beta squared is going to be 1 minus this entire term, right? 1 over kinetic energy over mc squared plus 1 squared. Now we have to take the square root of both sides in order to get to beta. So square root of 1 minus 1 over kinetic energy over mc squared plus 1 squared is going to give us the beta. So if you plug in the values, for the kinetic energy, put 7.5 times 10 to the power 5 times 1.602 times 10 to the power negative 19 m. Here, as you know, this is the mass of an electron, 9.11 times 10 to the power negative 31 kilograms. And for speed of light, obviously, we're going to get 3 times 10 to the power 8 meters per second. So when you do the algebra, we're going to find our beta to be 0.914. 0.914, which means beta equals V over C, right? Which means the speed of this electron is basically 0.914 times the speed of light. Now, in part B, we're asked what would change, what the speed would be if we approach this problem in an Newtonian way. So the kinetic energy, not a relativistic way, right? The kinetic energy would be 1/2 mv squared. Then from here, we would isolate the speed. So it would be twice the kinetic energy divided by the mass. Taking the square root of this, it would be equal to the speed. Then we would, for the kinetic energy, we would put 7.5 times 10 to the power 5 times 1.602 times 10 to the power negative 19. So this would give you the joules, right? Divided by 9.11 times 10 to the power negative 31 kilograms. So if we did everything correctly, what we have is 5.14 times 10 to the power 8 meters per second. Well, this is greater than the speed of light, right? This number is greater than 3 times 10 to the power of 8 meters per second, which is obviously a huge violation, right?